In this video from chapter 3, we're going to define what's called the theoretical yield and the actual yield, and then find how we can use those to calculate what's called the percent yield. So in theory, the theoretical yield is how much product we can make based on the amount of starting materials and the stoichiometry of our problem. So that's similar to the calculations you would have seen in the last video when we were asked to find the actual amount or the amount that we predict in theory that we can make of silver. So the actual yield is different because not all reactions will go to completion. They never go to 100% completion because of side products or impurities, things of that nature. So our actual yield will always be less than 100%. So less than our theoretical yield. So when we find our percent yield, we're going to use this equation here where our actual yield in grams, say, is divided by the theoretical yield and then multiplied by 100. So let's take a look at sample exercise 19, and we're going to be asked eventually to calculate a percent yield. So we're told here that we start with 150 grams of our iron oxide here, Fe2O3, and we're told that this is the limiting reactant. So we want to know what the theoretical yield of iron is. So 2Fe on the product side here. So since we're told what the limiting reactant is already, we don't need to know the amount of CO, carbon monoxide, that we have and determine our limiting reactant. So we'll just get started here. We're going to plug in 150. Notice there's a decimal after that. So there's 3 sig figs here that we'll retain throughout our calculations. First, we get to moles as always before. So we'll divide by the molar mass of iron oxide, which is found from 2 times iron plus 3 times oxygen to get 159.7. And we use the balanced equation here. So for every 1 mole of Fe2O3, right, that'll cancel out with this up here. We can produce 2 moles of iron. And we want to know this theoretical yield in grams. So we're going to multiply by the molar mass of iron, which is 55.85 grams per 1 mole of Fe. So again, we just multiply across the top, divide by the bottom, and if we retain 3 sig figs in the end, we would find we could produce 105 grams of iron. And let's take a look down here. That was our theoretical yield. But if we did this reaction and we actually only produced 87.9 grams, we're going to plug into that equation that was introduced above, where we have our actual yield divided by our theoretical yield times 100. And this will give us an 83.7% yield.